And
We
we
still
also
need.
need a minutes taker.
Yeah,
I
that
think
we
actually
do. That we do
need,
need.
yes. Okay, but it's 2 o'clock now in Finnish time, so 12 o'clock in UTC, so we can start. So this is IPsec maintenance and extensions working group, Psecme, first thing in IETF 112. I'm Tero Kivinen, and co-author is Joab here, and our responsible AD is Ben, who is here. Good. Okay. So this is the note well, and I guess you probably have seen it a couple of times already. So let's go forward. So we need some note takers, preferably two. I have already, filled in the basic notes into the heads doc or Etherpad. It used to be Etherpad, so you can go there and start just editing and adding what happens really in the discussion. No need to take any of the presentations. So anybody willing to be taking notes? Let me see if there is anybody suitable people to point at.
Paul has
Oh,
volunteered.
yeah, I was just looking for him if he's there. He knew that. All right, so thanks, Paul. And if somebody can help, because I guess Paul is probably going to be talking at some point. He usually is, so help while he's talking also would be good. I think the Meetecho link and the Jabber link and notes links are still. Well, actually, no, probably the notes links are probably wrong because it should be now in the notes.etf.org.
So Donald Eastlake and Jonathan Hamill have
Okay, good,
agreed
good.
to help.
Good. All right,
Thank you,
so
guys.
let's go to the agenda. So this is our agenda. So we have 5 minutes for agenda bashing and other things. And then we have 10 minutes for document status, and then we have 20 minutes or more for IPTFS. We now have enough time this time compared to last time, so we are going to be staying on that topic until we are done with it, so we can get the documents out. And then we have 5 or 10 minutes about the quantum rested equation 2 and big keys, and then we have 2 presentations from Valerie, which are actually most repeats from the previous ones, the group key management using IC version 2 and the announcing support for authentication methods in IC version 2. And those both are in the charter, and they are items that we haven't been discussing for some time, and we should be working on those too. Any comments on the agenda? If not, we go forward. So the first one is the document status. So we have one document, IC version 2 intermediate that is now in the publication requested state, waiting for the ADs to pick it up. And then we have the IPTFS group, which hopefully actually I think the first 2 name of the drafts are wrong, because I think they are now IETF IPsec ME, not the Hobbs and Fedic, but there is a redirections for those, so they should work. Those 3 first documents should be ready to go to the publication requested almost immediately after this IETF finishes. Or actually, I think the young and mid one still needs the separate write-ups, but for the IPTFS main document should be ready immediately when we get these final issues resolved. Then we have multiple key exchanges, which I think should be ready also, and algorithms, IC version 1 algorithms to historic should be also getting ready and labeled IPsec. Paul was saying that he doesn't have any update for those. He just needs to be doing some write-up for them and to get them ready going forward. Then we had this IC version 2, IC version 2 version that is still waiting there to be, to be needs more reviews. Let's put it as we have a discussion about that later. And okay. And then we have the, okay, Valerie, do you have something about that? Go ahead.
I just want to say that RFC 8229 seems to be ready for last call. The last revision is didn't change anything, and Tommy and I think that the draft is ready for last call. So it's quite stable and mature.
Yeah, my understanding is both of these are actually should be ready for the, to go to the out from the working group after the IETF quite soon. Oh, actually, the IGI version 2 probably needs more review still, but anyway. Okay, then we have, actually I have the more text about the group key management, need more reviews. The announcing support or authentication methods in IETF 2, we have a presentation about that, and I think it should be ready for the working group adoption call because it's still not the working group document. And as I said, I think the RFC 8229 is ready for the working group last call. All right, so anything else about the current documents? We have a couple of where is it? Stuff here. We have a couple of documents that are not the working group documents that are still in the list. They have compression and that kind of things, but we haven't heard anything about those. So, if there is people interested to get those one ready, they should be start discussing the working group list and start progressing those. Oh, somebody was asking to add IPsec. I don't remember what happened that in last.
So there's a question in the Jabber room if there are any plans to issue a working group call for adoption for draft BTW additional IPsec and EIC.
Yeah, probably we should be doing that. I think that's also ready. So we should actually probably start that, add that to the list and add that and the announcing our supported authentication methods in IETF 2 to the working group adoptions.
Mm-hmm.
And I don't think we actually need to wait for the ADD discussion to adopt it as a working group document. So we can actually go ahead with that. All right, so let's if there's nothing else, I think we should start with an IPTFS presentation. I think, Christian, if you start with your presentation first, and I will jump in at one point to present the other things that I have there.
Hi, yeah, that sounds good. Okay, the bars are moving, so I think you guys can hear me. All right, so yeah, this is a presentation on the status of IPTFS. Next slide, please. 2021 recap. In February, we completed the working group last call. We received some post-working group last call comments. We updated the document to 08. This was from Valerie wanting to change the language kind of like everywhere, to get away from IPTFS and talk more to the to talk about the encapsulation as ag-frag, because he felt it could be reused elsewhere. In April, we submitted the draft write-up. July, I did an update clarifying. We had one change earlier to talk about how the replay and reorder windows could be made the same, because if your reorder window dropped packets, who cares, or vice versa. But we needed to update that same text again because people might want larger replay attack windows because they're very cheap, right? You can have 2K entries in there, and it's not a lot of memory to keep track of that. But your reorder window, generally you want to be small. I think we've kind of reinforced that through multiple updates, that the reorder window needs to be small. But yeah, to the next bullet item in September, we added, and I think this was probably the most important change in my opinion. We weren't, before we had talked about you could use a drop timer if you wanted, and based on Taro's sort of analysis, you really don't want, if you have a slow sending link, even a medium speed link or whatever, if you have, if you're just using the reorder window to drop packets, then the size of reorder window determines the amount of time that it takes to detect a lost packet. So, a lost packet could then incur a large delay in downstream packets, inter-packet delivery. So, so the drop time, we added we instead of talking about the drop timer, hand waving at it, we actually mentioned it up front, and furthermore recommended its use. It's important. It's important to put a drop timer in, because it will then directly affect how long of a delay you're willing to take from a dropped packet. And so that the end result of this is that you just don't use reorder window as a way to detect packet loss. You use a drop timer. I've implemented this, and you don't actually have to use a timer, right? If you're using the way the document talks about constant send rate, you could just have your drop timer be 1 packet gap, right? So you literally just you can have your window sitting there, and if you get one out of order, you consider any previous dropped, and that implements a drop timer of 1 gap interval. So that's how we chose to implement it. But you can do it. You can use a timer as well to do even shorter delays. I felt like this was what we needed to do. I thought this handled everything. Taro didn't agree, and so we asked for an update. Eventually, I just took a guess at what would sort of satisfy Taro. I think I got close, but no cigar. So 11 had a small, we'll highlight why in the next few slides. I put in some text, which we'll go over, and Taro made a suggestion, changing a should in may. And I think that's what this discussion is really going to be about. Next slide, please. Right, so the last issue to resolve would be the difference between what's in 11. I'm happy to accept the text as Taro put it but I'd prefer to see the should and mays change. Primarily to go back to what 11 says, but using Taro's text. It's a little bit more verbose and descriptive. So let's go to the next slide. So in 11, this is the text we added. We say, as an optimal optimization, the receiver may transmit any fully formed inner packets prior to reordering the outer packets. This just means that if I have a full packet, no matter what order it comes in, full inner packet, I send it along. We had this as a may. So the next slide shows Taro's suggestion. This is the proposed text from Taro. It starts off with that concept, and furthermore, it recommends it. It says the receiver should process the payloads and send as many incoming packets from it as possible. So in a perfect world where you don't have any reordering or anything, it looks the same. That's one thing worth pointing out. If we don't have reordering, then both of these, no matter what we pick, it looks the same. But if we do have reordering, then Taro's will send some packets out of order to get them downstream faster. And then Taro, I don't know what the next slide is. Do you want the? Yeah. So let's do your slides. Let's talk to your stuff.
All right.
Why you want that?
Let's if I can. Yes, here's my. So I made this kind of slide set to try to explain it a bit better what's the issues, and so So this is the original text, or this is the text actually. This is the original text, and one of the things, their problem there is that there's lots of places where it's actually talking, implying that you do, like the last paragraph, for example, there was not clearly saying that it is should or may or what something, and it was like not really going with the one where we say the optimal optimization when you still say that we process the in order, and that's why I wanted to rewrite most of this text to be so that we actually have two different options. So so that, like it implies, it doesn't explicitly say it, but it implies it in several places, which was the original problem in the May or in the springtime, was that I didn't really understand that, but actually requiring that until when I finally understood that from the discussion with other people that it actually does require that all the time, and the text is written in such way. And so if you check out the normal flow when we have a packet coming in. So the O1, the blue one there, is the this is like from the responder point of view. So this the whole text is in the responder processing time. So we have O1 with this outer bucket, which has 2.5 buckets in. So when we get that one, we can immediately send out the 2 inner buckets that are complete. We can't send, of course, the third one because that's not complete. Then we get the next frame, and then we can send the third and fourth bucket out, and then we get the third outer bucket. We can again send that. This is like what it happens. So so it sends immediately completely fully packets out. And this is fine. Everything works. Then we come to if we have any kind of reordering happening there. And now, as it's saying in order, this is actually not the reordering. Is actually not that big issue. So we have an O3 and O2 are changing places. So we have an O3 first and an O2 first. In order, we have to wait until we get the O2, and then we can process the inner 3, 4, and 5. We send them all back to back when we finally get this O2. If we do this in immediate way, immediate when we get this O3, we can send the I5 out because it's already, we have it completely. And then when we get the O2, we send out the I3 and I4. The difference there is mostly comes when we have a lost buckets, or if we have non-constant bitrate sending. Because as Valerie was saying, we actually want to be able to do this kind of things, with non-constant bitrate, and the drop timer only starts when we get the O2. So when we get this next bucket, then we can start. So if we have a lost bucket, so we have a lost frame here, the O2 is lost. Okay, if we do in order processing in O3, we notice that there is a frame missing. We continue waiting for it. In O4, we realize that okay, if we have a reorder window of 2, or we have a drop timer of that long, in O4 we actually realize that okay, that was actually missing, so we send an O5 inner 5 and 6 and so on out, all the back to back. The problem is that if the O3 doesn't, if that comes much later, like we are not sending constant rate, we are not really, or sorry, actually O4 comes out. So it actually, or if you have a longer, like we have here is a longer, if you have a reorder window of 3, we have to keep all of those O3 and O4 and O5 in memory until we get the enough time from last time. And so we actually use much more memory and we cause delay. And we have, already lost frames, so it doesn't really. Yeah, go ahead.
Yeah, I mean, I wanted to let you go to the end, but I have to point out that this is not considering a drop timer, right? It's important to know.
No, it's assuming that drop timer is actually larger than any of these.
I mean, you're basically pointing out that if you're waiting for the reorder window to note O2 is not there, that you can have this huge delay, but that's why we put the recommendation for the drop timer in.
Yeah, but the question there is, what is suitable value for drop timer? I have no idea.
O3, 1 packet gap.
But there is no packet caps. If
So
you are not using constant data rate, what is the suitable?
Correct. So yes, in the text we say that I believe, and if not, we should change the text. But I believe the text says that the drop timer determines the delay, right? So whatever you're willing to accept as a delay is what you set your drop timer.
That's the problem. I have no idea what the delay I'm going to be accepting.
But that's operational, right? I mean, we don't.
Do you have so what is your recommended drop timer timeout in your environment now? How many milliseconds?
We use a constant send rate. It's 1 packet gap.
And how much is 1 packet cap?
Well, that depends on how fast you make your tunnel, right? If it's a
no, but I mean, I want to have.
One size does not fit all for the whole internet, right? If I have 100 gig tunnel, then 1 packet gap is tiny, and that's still appropriate. If I have a 1 megabyte tunnel, then a 100 nanosecond gap, is not appropriate for 1 megabyte, 1 meg tunnel, right? The delay should be much bigger. In our case, it's exactly scales to 1 packet gap. But people, it determines, that's a knob, and it's a knob for a reason, because it's
my understanding is that if we have an reordering happening, real reordering, that usually means that you have 2 paths that the packets didn't take the same path. If they take the same path, there should be no reordering happening. The only way you can actually have a reordering is when you have 1 packet goes through different transit network than the other one. And in that case, the delay caused by that might be orders of magnitude bigger than what is your 100 frames per second interval. It might be like half a second or second instead of 10 milliseconds.
Yes, and we speak to that in the later slides in the deck, right? But that's why, yes, that's why you don't want reordering. You don't put a single. We've designed the internet routers. I'm a router guy, right? We've spent a huge amount of money, research, and whatnot. I'm not reordering flows, right? Because TCP will not accept its packets where you have 2, 3, 4, 5, 1, 6, 7, 8, 9, 10,
no,
11,
it does. It does. No, it actually sends a selective action saying that 1 is missing.
I've got some papers, right? TCP is not designed for that. You want to crank down a 100 gig tunnel to 24 kilobit? Try that. Okay, but you can't. You cannot send it. Yes, Are you arguing that we haven't worked really hard in the internet to get rid of?
No, that's why we are working very fine with trying to get things like selective acts and so on working. So in case that we actually for the responder point of view, it's actually no difference whether actually 1 was retransmitted or if 1 was actually just delayed because of the reordering. So it actually works.
You just said a half second. You said a half second delay, right? I mean, I can't speak to that.
Half a second delays are very common for me, at least.
In a single a half second reordered delay on a single flow.
No, half a second delay for packets randomly appearing. Actually, 1 second delay for 1 link. In my house, I see this very commonly that every 10 seconds or something. Suddenly I have a 1 second longer delay on 1 packet than in other packets.
But
and if I have 2 different links going out, they are going to be using. There's going to be 1 second or half a second of delay when it actually arrives. If I would have multi-homing system.
So you don't use 5 tuple to ECMP balance off those links. You just randomly round robin your TCP across.
No, as I say, I don't use. That's one of the problems. I can't use the multi-homing because of the links are
because it
different.
Does that, right? That's what I'm saying. People don't deploy those solutions, right?
But you use them in case you have a backup link.
Okay, but my point.
But anyway,
everything is designed to get around this, right? We don't. Yeah. The internet is designed to not do this.
But the difference is that if we actually don't use a drop timer, but instead of when we actually have when we receive the O3 packets. And we noticed that, okay, we have a full packet of I5 there. We can set it out immediately. We still need to, you know, buffer the end of or beginning of the I3 from the O1, because we haven't still seen the, you know, the end of the I3. We seem to have missed it I4 or whatever. Actually, we don't know how many packets we actually missed in the beginning, in the middle of O2. But then when we get O4, we see, okay, yes, we can send it. And now if the O2 arrives like 2 seconds later, we have only buffered the I3. We have very limited buffers in the memory, because we only have to buffer those fragments that are part of the missing frame. We don't have to buffer everything. We only have to buffer that one piece that was actually missing, or that the pieces of that bucket that is missing. So we, you know, for each frame that we are actually missing, we actually only need to buffer a very small amount of time, and we are not tied to the fact that, oh, we are sending constant you know, these, because in some cases it actually, we might still want to have a drop timer and so on. The other thing is that there is, you know, the IPsec does not provide in order delivery. That's not guaranteed. If we turn off IPsec in for example, in this reordering case, we are going to get these packets in wrong order. If we have a reordering happening, I don't think it's IPsec point of, or sorry, IPTFS version of the IPsec should be fixing that reordering. In general case, if we have an IPsec without IPTFS, we can't fix the reordering because we don't know it happened. We have no idea of knowing it, whether it happened or not. Sequence numbers doesn't allow us to do that. In IPTFS, we defined so that the sequence numbers allows us to do that, but that's a new service we are providing, which is not part of the basic, you know, no IPsec case, or it's not a case when you have a non-IPTFS. So that's why I think it's important. We don't actually try to fix something that wasn't problem before.
But IPsec also doesn't let you aggregate 20, 40 byte packets in a frame either, right? I mean, we're bringing new technology here.
We are bringing, but
it's not just about it's not just about reordering. That just falls out from it. But part of this that appeals to people, the reason Valerie and other people are looking at this in a non-constant send rate is because it solves the MTU issue, right?
Yes.
And part of that is you know, it's just all part of a package. The ordering drops out of that. And as you said on slide 14, I want to just point out, when you were at slide 14, you said, if we don't have a drop timer, we are recommending a drop timer. We are recommending it. So so just keep that in mind. You know, as the working group thinks about this, I want everyone to think about the fact that a lot of the problems being described here have to do with using reorder window as a drop detection, and we are not recommending that.
Yeah,
so we recommended a solution to get away from this problem.
So you're effectively getting rid of the reordering window in number of packets. You are only using it as an, you know, number of timer. But I saying that defining that timer is.
I'll tell you why we use it for exactly the case you talked about, right? When people want to use this for either, you know, well, one, line rate stuff, right, where there is no packet gap, or were they not doing constant send rate, like people that want to use it just for MTU solutions, right, where packets come whenever they come, right? That's why the reorder window is useful there, because you're willing to wait a little time to get out of order delivery, right? Because I got packet, and then a big pause. Those 3 packets might arrive out of order. A reorder window makes sense then, which that reorder window will put things in order before the drop timer hits, because those packets are coming back to back. They're just slightly reordered because they went out of, you know, whatever queues slightly behind each other. So the reorder window still makes sense, but only in these cases where, you know, where the drop timer doesn't fire. So when you're pointing out that, well, now you're just making the reorder window 1 slot, right? That's only a constant send rate, right? So for all these other use cases, a drop timer with a reorder window still makes sense, and it doesn't incur these problems.
Yeah. Okay, so there's other people in the queue. Let's allow
So
them to go first.
Let's let Ben join the discussion. Yeah.
Okay, so I was trying to take a few notes, and there seemed like there may be a couple of topics that we hopefully could disentangle and make sure we're not trying to overconflate too much. So let's see. Christian, of course, was talking mostly about the environment where you are doing the constant send rate, and so that your drop timer has a fairly natural setting in terms of one inter-packet window. And I know that Tero is at least partially considering the case where you're not at the constant bit rate, and so you might not have this natural setting with a drop timer. You, of course, could still use one, and the right setting value for the drop timer is an operational parameter that we may not have the right guidance for right now, but we could still say that you would want to use one. So I guess one thing I wanted to jump in and sort of focus the discussion was to make sure that we were sort of considering both of those cases. And I think in the stuff that happened after I joined the queue, I think that was starting to happen, that we're making sure we consider both the constant bit rate case and the sort of more generic agfrag use case. And let's see, I think also, Christian, you were doing a great job picking this up right before I jumped in to point out that you can have a little bit of a reordering window that performs sort of a separate function than the drop timer itself does. And so I think I was just taking some notes as you finished up, like we might have a fairly small reorder window or reorder time interval, and then like the drop timer would be significantly bigger than that, I guess. And so you would still have the ability to do a little bit of reordering fix up before the drop timer would kick in. And that's sort of what I heard you saying.
When you have your reorder window can be big then, because you're not gonna wait because you drop, right? You drop on the timer. So the reorder window then it's really just a function of how many packets you're willing to wait for, but you're never waiting more than the drop timer. So the drop timer is really the thing that's determining how the delay. That's why I said if the text doesn't make that point, we should make sure it does. But I think
it doesn't actually. And one of the things that's actually is what when I proposed in one of the earlier emails was the hybrid mode, where we actually we have a certain value where we assume that we have a very short timer. It's not a drop timer, because drop timer is actually wrong term, because we are not dropping the frame at that point. We assume that the frame might have been dropped. So we assume that after
sounds like splitting hairs there.
So no, but sure. I mean, drop timer would actually imply that we drop all of the frames that were actually assume it to be dropped and forget everything from that. We don't want to do that. We want to just say, okay, after this time we assume it's the packet was lost. The lost timer is actually a good idea. So we have a lost timer. After this, we assumed it was lost, and we send packets out immediately after that. We can still have a much larger reorder window, which actually means that we actually keep the parts of the 01 that hasn't been sent out, like the E3. We can keep that for much longer time, because that's a very short amount of small memory. And then when we finally, if we ever happen to get the 02, then we can actually send it out of order now, because it's outside the drop, this lost timer, but inside the reordering window.
Hey, Tero, can we move back to my slides? Because I think where Benjamin was going, we have a solution here, right? Which is back. Okay, back.
Which one?
I think I had maybe two more things I want to say.
This is what Lou put on the list.
But actually, if Ben wants to finish first, or
yeah, Lou. But Ben, can you take a look at that, because we think that we're close, right? So we think the resolution here is really just about where the shoulds and mays go on Tero's text.
Right, and one of the things I wanted to say was that we have some good thoughts about this, but it's also possible that people in the broader IETF are going to have some thoughts on this. And so maybe one option to keep in mind is to like put a note in the document. We had a long discussion about this. We could go either way, you know, let's get some feedback as part of the last call. We could, you know, for example, specifically call it out to the TSV area directorate review and say like, we can, as a working group, reach, you know, a tentative conclusion or, you know, a set of just two things that we could perhaps be happy with either of them and get more feedback later in the review process.
Okay, so the bottom point says like make them both mays in a configuration, that we're not locked into either behavior. I mean, if we're gonna, I don't think we should hold it up for a big long, you know, if we're not locking anybody's behavior out then. I mean, rather than just keep going through reviews and reviews, let's just allow both behaviors and let the configuration stand. And then you can have operational experience down the line, right? Because people learn, oh, you should really set it for this in this environment, and you should set it there for that environment. But we can't just wait, you know, the research is, we can't just wait for a bunch of research to happen, you know, before we publish a working, you know, we have working solutions here. Let's get them out. I mean, that's how we do it in the routing area. Generally, when we have two working solutions and we can't come to an agreement on which one is better, we generally throw a configuration knob at it and say, you know, let operational experience dictate the correct solution. So I think that's what the second option there does. It really doesn't lock us into anything, right? It allows both behaviors, and it allows people to, you know, pick which one seems to work best for them. And eventually we might, you know, learn that, hey, this one is always the better one, or 90% of the time, this one's the better one. But yeah,
Right.
I think that's what you're going for then.
Yeah, I always feel a little bit uncomfortable when I see drafts coming through. You mentioned the routing area, which does this a fair amount. And you know, I personally would prefer if we could pick a single solution that we know we're happy with, but I recognize that sometimes we can't. And I think I can't remember actually any times where something came in through the ISG review that had multiple options, and we were able to say, no, you don't actually need all of these options. We should cut it down. So
right.
It's a little bit of precedent.
It's like 640K is enough RAM, right? I mean, if sometimes when you make a choice, you make the wrong choice, and then you're in trouble.
Ideally, we could have guidance. In these cases, you use one configuration. In those other cases, you use the other configuration. So I'd like to reorder the cube just because Luberger's text is on screen. So I'd like him to go before Valerie.
Yeah, let's go ahead and do that. I will rejoin the queue and make a couple points later.
All right. Well, thanks for letting me go out of queue. I would have been fine sticking behind Valerie, but thanks. I was actually going to go back to a point that Tiro made, I think is really the critical one, is that when these weird delays happen, as he talks about, you know, your experience at the edge, your protocols are built today to recover from them. What they are not always built to do is handle massively out of order packets. And I've seen certain transport protocols that will basically do a connection reset when they get something that's too far out of window, too far delay. Sometimes they think it's actually some form of delay attack. So I think, you know, going to a mechanism where we experience it today is safe. You know, adding some delay is something that the internet is built on today. So that's a safe approach. Amplifying reordering, I think, is a risky approach for many transport protocols, and at least it requires some good research, exploration, experimentation. You know, we found one paper which talked about TCP having a really hard time when you get two out of order, and because we have an amplifying effect with the reordering, because we're carrying multiple packets, you know, we might end up with lots of ACKs out of order. You know, a big chunk of ACKs or a big chunk of small data out of order. And we just don't know what's going to happen. So from my perspective, it seems really risky to recommend that as a should. And I think we have to allow for the operational experience, the market experience before going to a should for that, which is why I said I was comfortable with it. I could live with the may. I'm not saying, I actually think the should be the other way. but I can live with a may.
Yeah. So you are actually assuming that we have multiple buckets for the same flow in same aggregate frame, which I don't think actually is going to happen. We are going to have multiple flows. There are different flows that have pockets, because I mean, if you have multiple buckets there in the same flow, that actually means that your send rate is a bit too small, or somehow you are sending, because I mean, in cases where you actually have a transfer like in TCP, it actually sends full frame. It sends big buckets when you are sending lots of data, and when you have a sending back-to-back, buckets, and they are going to be in separate, aggregated frames. So in that case, actually, the reorder is going to be only one frame.
Yeah, I mean, it depends whether you're, if you're doing, if you're thinking about a in the middle of the network, you probably have.
We are in the middle of the network. We are in the middle of the network.
If you're thinking about IPsec at the edge, it's not, and it'll depend on a little bit about what the flow of traffic is, whether you're doing an upload or a download, right? So it really depends on where you're operating.
But
and
IPsec is defined to really be this. What we are really concentrating is the security gateway to security gateway connections. That's my understanding for IPTFS. It's going to be protecting gateway to gateway connections. I don't think anybody's actually willing to be their laptops having multi-gigabit constant feed data from his point to the security gateway of the office. I don't think that's actually.
If my VPN appliance lives in my basement and talks to my office and does TFS, I may not have a whole lot of flows across there, and it's still that use case that you just described.
Yeah, but
we're looking at use cases from anything up to tens of gig down to basically office remote access. Those are sort of the cases that we've been considering.
So the question is, why would the download or uplink or whatever protocol would use less than full frame packets when sending lots of data?
The constant send rate thing that we're documenting, right?
No. We are not talking about. We are talking about now data inside the constant aggregated frames.
Right. So you were asked how you could have multiple small packets. How you could have multiple small packets in one outer packet. That's how you're waiting to send the outer packet.
So
true. But yeah, okay.
So the basic point I wanted to make, and I'll get out of queue, is that the way you have it makes a very strong assumption on what applications can handle, and I'm worried that you're going to start breaking things if you say should. So I'm really uncomfortable with going down an approach that may yield a non-functional solution, and we just don't know because we don't understand the full scope of applications out there. So I think it is too risky to use the should the way you have it phrase it. I would love this to be done with this. I mean, we've been sitting a long time trying to get this document out. I would love just to accept it, but I think it is too risky to take the approach that you're recommending. Thank you.
Okay, and now despite the reordering, we're going to process Valerie's input. Valerie?
Well, I want to bring attention to one potential issue with.
Valerie, we can barely hear you. So something with the microphone.
Can you hear me?
Barely.
I can speak loudly. So
okay.
Can you hear me now? Okay. I just want to bring attention to one potential issue. Probably it's obvious, but I think that it escaped from the discussion. Tara, can you please move to your slides? And okay, next. Oh, this one. Okay, previous. So you can see that if we keep an order of packets, then packets I3, I4, I5, I6, I7, not only delayed, they're all sent as a bunch. So this may cause a congestion because if in usual operation, when there's no delay, there's no packet lost, outer packet lost, or reordering, packets are sent, internal packets are sent with pretty constant rate. But here we not only have a delay, but we also have a bunch of packets sent at once. When they are assembling, they are all sent at once, and this can cause congestion. It's probably a theoretical issue, but I think it's not. It must be counted. Well, just want to bring attention to this.
I think that's a valid comment, Valerie. I don't think there's, like you said, it's a theoretical thing. I think we have to look at, and we'll get an operational experience as we get it out there, right? Like, what kind of burstiness does TFS cause, right? Because there's a certain amount of burst. If you do a constant send rate and you're aggregating a bunch of packets, right? You're only getting the outer packet on this at this constant rate, but then you get maybe 5 or 10 packets in a outer packet. You send them all at once, right? So I think we haven't seen any problems with that, but we're not the internet, right? So once we get this out there, we're going to find out, oh, this doesn't work in these scenarios, or you've got to limit things, you can't, aggregate too much. We don't know those things, but yeah, I think it's an interesting and important observation.
I think that as Ben suggested, to attract transport area experts, TSV review is a good idea. But I just want all this consideration, even if you choose May for both, just an operational condition, operational handle. I think that all this transport consideration should be documented in the draft. So what we'll have if we use this option, and what are advantages, disadvantages, and what can happen. At least it should be documented. That's my opinion.
Yeah, I agree that we'd like to document things, but you're going to quickly turn into, we're not the transport area. This is an area of study for them still, right? I mean, we don't want to overstep our boundaries here and try to talk to things we don't understand, right? So saying this is good for this environment, we don't know that, right? So I think we could say that TFS adds can add burstiness to it. We could add that that simple sentence covers a lot of it.
My understanding.
I want to move to a picture in my slide because I think it also speaks to this.
I want to verify what Valerie was saying. So Valerie, you say you want us to document what are the effects of having delays. You want to say that there is going to be delays, there is going to be burstiness, or there is going to be reordering in groups. Yes. You want all of that to be documented. You don't want to speculate what it affects the protocols, but you want to have that documented so the transport area can do that. Okay, good. Yes. And I agree on that, actually.
I don't think we need, I think that's good. I also don't think this is a lot of verbiage we need to add, right? We don't need a major redesign here. We just need to note in the paragraphs you suggested, Taro, we can even say this can result in this, we could, we'll get to that slide. Show mine, because that'll be something I want to put in.
Yeah, and I think that's a good point to make.
You had it, the picture.
We've heard a lot of things in the live discussion here that, would be nice to write down somewhere, but I think when we go and figure out what actually needs to go in this document versus what could maybe be a separate draft that's just sort of almost a living document to incorporate the additional stuff that we learn over time. I think we should try to not put everything that we talked about today into this document. I think Christian and everybody, you point out there's a few things that are probably pretty small that we can put in this document and are worth doing. But I think there's also a lot of other things that we should write down, not in this document.
Yeah, throughout the picture, it talks to this. Lou mentioned the amplification, and I want to show that because that's what I would probably put in the line. It's a little bit further down. I think slide 9, maybe. Yeah. So this shows a picture of a lot of misorder. I'm showing a picture of here a common scenario, right, where you get a misordered packet, but they're not. Since we're not talking about constant send rate, I wanted to highlight that the misordering is often going to happen. You get one just before the other, right? because it just took a slightly, it paused in a queue or whatever. I mean, mostly we don't, like you said, Taro, if this is a site to site and a UDP, we don't expect a lot of misordering, right? But if we do see it, I expect it's going to be like this. And what can happen when you get this is, if you look at the top of the diagram is just normal delivery, and it even shows somewhat of Valerie's point of the burstiness, right? Of when you're aggregating that you send the inners, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When you get the misordered, we're getting the second one a little bit before the first one. And what happens is that then we send the first, we have 6, 7, 8, 9, 10 to send. So we send them. And then we have 1, 2, 3, 4, 5, and we send those, right? And this is what Lou is talking about, where we're amplifying the out of order delivery, right? We've only got a 1 packet out of order on the tunnel, but we've made the user, and what the user sees at the end, it's got 5 packets. This can start, we're worried that this could start really triggering, TCP, gets outside of the windows. I mean, who knows, right? These are these transport questions. When do things break, right? And this amplification is scary to us. I make ours look nice because, in this particular case, ours looks nice because, the delivery only adds a small delay and you get all the packets in order. That's not going to be every case. I'm not trying to say, ours is the best. Look at how great this diagram is. But there are definitely cases. This is going to be a common case where the small delay is not a big deal and TCP and whatnot can deal with it. But, transport protocols might not be able, in this case, to deal with the large amplification of out of order delivery. This is just one case that I wanted to cover. And why we think
that gets into the sort of, there's many different potential use cases for this technology. Some of them will involve only a handful of inner transport flows being aggregated into the single outer flow. Some of them will involve a huge number of inner flows being aggregated. And so trying to make an assumption about, are all of the inner packets going to be from the same versus different flows is probably not something that we can make a guaranteed assumption about here. And so that's sort of leading me to conclude that we kind of have to do the may and just add some additional text about, in certain circumstances, one versus the other might be preferred. We have some thoughts about this right now. These are not the final thoughts on that. Is there anyone else in the queue? I had one final thought. So I guess one of the things I got up in the queue to sort of mention very early on was that, like, if we think about a traditional router in an IP network, it's not looking at the flow. It's not trying to do any reordering here. And in some sense, if we think of the IPsec building block as being vaguely analogous to that, my intuition would be that this router-like thing should just take what is given and send it on without trying to store too much state. But then I think the discussion that we've had just right now during this meeting has sort of convinced me that's not exactly the case here, precisely because, and I think maybe Lou was the first one to bring this up, we're not just moving a single packet at a time. With the aggregation, there's this risk of amplification. And I think the risk of amplification is sort of what's convincing me that that we do want to diverge from one packet in, send this output right when we get it. I think that was all I had queued up in my notes. So I guess to try and
I had a slide before. I don't know if it's important to show at this point. This was just me making the case I kind of just made, which is, I think there's going to be a lot of cases where things just work, right? But we don't have to dwell on this. I think we're getting to this is the discussion I think we needed to get to, right? Or we need to resolve. So
right. And I think my sort of summary, my sort of summary here is that we should say may for both of them, and we can put a little bit of text in to try and cover some cases in which one should might make, like, or sorry, in which
No, let's not do
doing the
should.
one might be
No,
good.
yeah,
Right, yeah, not should.
I think having may actually is okay, and I think what we should be doing, we should rename the drop timer to lost timer, because and then we actually want to define it in, because I think we're actually missing the text saying that after the lost timer, you are still not throwing the packets away. You just assume that the previous packet was lost. There was not a small reorder. This is like the hybrid mode I have in my, when I proposed the 3 different, one was the in order, one was mine, and one was the hybrid where I actually, wait for a short time to see if there is a, just 2 packets in out of order, and then, process them in order. And after a very short timeout, you realize that, okay, it was not just out of order, very short out of order. It was probably lost packets, so we sent packets out immediately. And that case, so I think that's what we probably need to do.
Yeah. So it does say in the drop timer recommend, it says only consider an outer packet lost when the reorder window. I mean, it does talk about it just considering that packet lost. I think we might be covered there, but I'm willing to call it a lost timer if you want.
Yeah, I lost a packet lost timer is better name than than the drop timer, and I think, and actually the same thing can be actually done. Actually, should be done regardless of which format you are actually using. I think whether you are thinking. Actually, they actually come to the one format if the lost timer is short enough.
Yeah, no, okay. So I'll change drop to lost packet in the text, and we'll change the 2 reds to may. That last final cross out, I think I made by mistake in blue. We could say drop lost packet timer, or we can leave full reorder window, or we can cross it out. I don't know.
Yeah, but then we want to add a note based on Valerie's comment about the burstiness, the reorder amplification, and delay.
So I think we add a sentence to each one of these paragraphs describing the, for the first paragraph, we can say this method can amplify out of order inner packet delivery. And for the second paragraph, we say this method can add, extra delay to the inner packet delivery.
And burstiness was the Valerie's comment also.
Okay, yeah, burstiness and extra delay.
Yeah.
Okay. All right, good. So those are like 3 minor, pretty minor changes, I think, and we make those, and let's go to the next slide then.
Who was commenting that the extra burstiness was actually already there?
So I think we're at a resolution, and I don't think we have any other issues. Does anybody disagree?
No, I think that's. I agree, and I assume you can get the new draft out very soon.
Yeah.
Actually, send a note, send the modified 2.5 to the list first. Hopefully, like as soon as possible, and then if there's no comments on that, then we can actually get a new draft, so we don't. And then I want to.
You know what? Drafts are cheap. I'll just publish the draft. If we have to do another one.
No, that's fine. Okay,
they don't cost anything.
and then we actually need to have a separate write-up for the Young and Maybe, I think, also. But I need to comment on that because I want to actually push them all out at the same time.
Okay. Yeah.
All right. I think, is there anything else on IPTFS?
Just one thing that if we do write about a drop timer or delay timer,
packet loss timer,
we need to have some packet loss timer. Sorry, yeah, we need to have some recommendation about how long it should be.
I disagree with that. I disagree with that. We cannot make recommendations based on. We have people that want to do 100 gig link, 100 gig constant rate send links. We have people that want to do from their house.
No, right? But actually, yeah, we can think about, we can add, say that it's going to be in the order of expected packet, bracket rates, That would be the order of it, especially if you assume that you can actually allow the reordering of the larger things. You just assume that the packet was lost or something like that. I don't know.
Okay, I think we're getting into areas that we don't understand, and we shouldn't go there. We don't know what effect, the setting. We're just taking a swag at it, right? We're writing
that's actually scary. That's why I don't like the idea that if we are running a protocol and we have a timer there that we have no idea what the value is going to be useful for that, what value is going to be useful. I think the administrator.
Okay, you know what? Deb in the comments said that why don't we just say that the lost timer should correspond with the tunnel, with the expected tunnel rate. It should be proportionate to the expected.
That's the only thing that I think we can actually say.
Yeah.
Okay, good. All right.
Depending on whether we use a concentrate or not, it's either the concentrate of the tunnel or the maximum rate of the tunnel.
Well, proportionate to the tunnel rate, and then that doesn't, it doesn't really lock us in, I think.
All right.
But that's an informative statement. It's not, there's no RFC 2119 language there, right?
Right. We shouldn't have should or may or,
No, we just have a comment or note or something like that. Yeah. All right. So if that's, and you will publish the new version of the draft and we will see that. Okay. Then, okay. I don't know if it's going to be Stefan or it's going to be who is going to be, okay, Stefan is going to be presenting this. Okay.
Hi, thanks. So Daniel is also with me. And Daniel and we started a mail thread called cost-efficient quantum-resistant DOS protection. And just to make sure this thread is with a D at the end, not with a T. So to prevent any misconceptions, we do not claim at any point that we shouldn't go for eigentermediate or the multiple key exchanges. So this does work. We've also tested it with Strong's one Seconet as well as with Valerie and his implementation. And of course it does work, but it is a somewhat complex solution. And there are a few pitfalls you have to take care of when implementing it and using it. And what we do claim in our mail thread is that we should have like a first barrier that is quantum resistant in the IETF init for quite a few reasons. First of all, there is not like the one single quantum resistant encryption scheme that is actually really secure. So not us speaking for a company, not the agencies, no one is really sure which quantum scheme to actually use. And we have to get around this at some point. So the current solution, eigentermediate and the multiple key exchanges, is to have it like in a hybrid way, to use several schemes in a hybrid method. And this does work. You shouldn't go for too many schemes at the same time in practice, but it does work. Still, we need some kind of fallback solution, because will there be one single like lattice-based scheme in the future? Maybe in 5 to 10 years, we will have the confidence that a single scheme is good enough for the next few years for some parameter sets, but right now we still don't know. And IETF is used in a lot of settings, and we do know about quite a few settings that are in the governmental or military context. And there they want to have a very secure solution, and sometimes they have quite good throughputs. It's not always that bad having, they don't have too lossy networks in some cases. And they basically want to have MegaLease, because MegaLease is really big. No one actually wants to use it, but it is like the security fallback to have. And you can use MegaLease in this context. The problem is like the 64K limit. And that's exactly why there is this internet draft for this beyond 64K. And this is not only talking about MegaLease in a CAM context. but it's also talking about signature certificates for quite a few schemes if you want to have like a quantum resistant scheme for authentication as well. And there you get quite a lot of complex state machines, and it gets quite messy. And there are really many denial of service options you could have as an attacker. And one easy way to go about it without doing a lot of multiple key exchanges beforehand is have like this very first barrier. So taking just one efficient quantum resistance scheme included in IGSA init. We still don't know if this single scheme is like really secure for the next 5 years. We just can't say it. But it is an additional effort that an attacker would have to do, like in the very first exchange of any data. So this might be quite a cost-efficient solution, and it would help for quite a few cases of denial of service attacks as well. And you might be able to implement it and also like implement IC intermediate and everything above it as well. So we've implemented it, and we've also done some measurements, and I think Daniel has a few graphics to show.
So can you hear me? Yes. Yeah, exactly.
We are not hearing you. We did hear you earlier, but
We're just gonna switch places.
All right, then we do it that way. We implemented all the drafts, actually, and let's do it that way. We implemented all the drafts, so intermediate exchange, the follow-up exchanges, and the beyond 64K limit draft, but not the current version, but the version before. The current version uses mixed mode, so TCP for the handshake and UDP for the actual payload data. What we did is just the version before, where we just use UDP, and we tested it for several different network configurations. So this is what we see right now. There we have on the x-axis the error rate, so like the packet failure rate in percent, and on the y-axis we see the handshake duration for each network configuration. So like each error rate, there were 100 measurements taken, and the underlying conditions were at this point 100 milliseconds of pretty constant latency and 100 megabyte of throughput. So it's like in German you would say like an average usual household connection. And there we see that as long as the package drop rate is not too high, it's like around, I'd say 10 seconds until the child essays are created, which we deem actually pretty acceptable for a solution that is for like setups with especially high security requirements, where agencies say, okay, this data has to be secure for decades, not just for like 5 years or something like that. And for this, I guess, we think it's actually a solution that is not too bad. Obviously, if you want to connect a large amount of mobile clients working over like cell phone connections, you get into trouble. That is clear. You also see it. We tested the same setup, but instead of 100 megabit, it was 1 megabit of throughput. So if you can show the next slide, please. And there we have a pretty clear distinction. So we're pretty fast at around 50 seconds of handshake duration, or even more than when the package loss goes up. And I don't think this, so this shows like less reliable wireless networks. And I don't think this is or just smaller networks with less throughput. And we don't think for this use case, this draft is fit. But already in the not mixed mode version, so in the old version, we think it's quite acceptable to use it for those special setups where the huge amount of security, long-term security, is required. Yes, still we thought should talk about where to use it, because a gateway having to accept like several megabytes or 1.4 in the largest configuration, megabytes of data from a non-authenticated peer just opens up the attack vector of just many peers sending these large public keys, and thereby exhausting the memory of the gateway, and so by this denying the service, and therefore has to be some protection against this attack. So we think putting it behind authentication, so each initiator has to authenticate itself first, and is then able to send the McAleese key exchange. In our way, we did this by immediately rekeying and only allowing the McAleese to be sent during follow-up exchanges. But as we talked or discussed already last time, this has some implications. So yeah, it's a decision to be made. I think it's not one like obviously right choice and all the others are wrong, but we should definitely talk about it, and definitely in the context of this draft, because this draft is explicitly made for allowing McAleese to be used. Yes, that's actually what I wanted to say. Is there any opinions about it? I think there was already a lot mentioned on the mailing list. We'd be happy to hear that now.
Go ahead, Valerie.
So first, I think that using UDP for transporting very large payloads, as it was in previous version of Beyond 64K, is not a very good idea. That's why we introduced a mixed transport mode. I think that it will solve a reliability problem, because well, your figures are very impressive, but I think if Psecme is used for IKE in this case, so this will be solved. And what about the solution you propose to make some combined key exchange that combines Diffie-Hellman with some post-quantum algorithm with small public key? I think it's not a bad idea, but first of all, it's orthogonal to the multiple key draft, because you can use it with or without. It's just well, multiple key draft makes one change to the IPv2 protocol. It remains Diffie-Hellman group to generic key exchange method, and with this change, you can define a key exchange method as you want, as combination of two key exchanges. So it's okay. And you can use it with or without multiple key exchanges, and it's just orthogonal work. What makes me what I don't like about it is that well, you have picked up a single classic exchange 25519 and a single post-quantum key exchange. Well, I think that it's okay, but not in all environments. There are lots of environments that will insist on using this particular post-quantum key exchange and this particular classic key exchange, and they won't be those that you have selected. So that's why multiple key will solve this problem by combinations. So you can achieve the same result if you perform IKE-NIT with any classic key exchange you want, and then following with a post-quantum key exchange with small public key like intermediate. And it will add you one extra round trip comparing to your solution, but much more flexibility. That is very important for some environments.
I totally agree. If I just can like directly answer to that, I totally agree, and I think for long term, the greater flexibility of follow-up exchange, like the multiple key exchanges and the intermediate exchanges, is definitely the superior solution. Still, for migration purposes, because the intermediate exchange does definitely add complexity due to its interconnectedness with authentication and the way the signature has to be calculated. And so currently we have to expect that agencies already record data to be able to decrypt it when they have a large quantum computer available later on in whenever that may be. And so we should like start using post-quantum cryptography better now than in a few years or a few months. So the easy solution of just adding, I don't know, 1 to 3 given fixed combinations that are like, there's no big protocol changes. There's, as you said, it's really low effort. And the adoption of this for many implementations should be pretty quick. And then to like overcome the transition period until the intermediate exchange and the multiple key exchanges draft is has a wide adopting, like wide accepted, not yeah, it's widely adopted by different implementations. And so because otherwise we still have a gap where we just use, as it is often as it is now, just use classical key exchanges like Diffie-Hellman.
I just want to point out that we already have an RFC 8764 for using mixing per shared key to achieve post-quantum security. And it was deliberately chosen as a short-term solution before post-quantum key exchange became mature. So you can always use this RFC, and it has, yes, it has some scalability problem there, but it gives you the full protection from quantum computers. So, and well, so I don't mind if you defined a combined key exchange as for me, but I think that this is orthogonal work. So you can write a draft defining how keys are combined, and for me, just for me, for some reasons of algorithm agility, I think that I'd avoid using some hashes and just make a concatenation of public keys, because if you stick with a hash function, you will use it forever. It's no agility. So you will change the whole combined method. Well, but it's in my opinion. So it's security experts should analyze it.
I think that is good input.
But so the bottom line, what I want to say, I think that it's not a bad idea, but it is not concerned with the current efforts to make multiple key and beyond 64, because I think they should be continued and to make workable and be published.
Yes, I think they might be like, if you use the beyond 64K draft and put the large key exchanges behind authentication, like we proposed, then you might run into the situation where you don't use a quantum secure key exchange before authentication, because an administrator thinks, well, I use McAleese, this is secure enough, I don't need another post-quantum key exchange. And then they have IKSA in it with the classical key exchange, they have authentication, and then they rekey or whatever, however it's structured, and run the McAleese key exchange. A attacker who lively, like in real time, decrypts, breaks the first key exchange, would obtain the shared secret, and this would allow him to, or them to, manipulate the message authentication code of the McAleese key exchanges. So establishing a full man in the middle position before the McAleese key exchange is conducted. So there would be another easier option to just deny that option or to deny this attack without even requiring the multiple key exchange or the intermediate exchanges, which doesn't mean you should not use it. So you could still say you use IKC init with, I don't know, classical Diffie-Hellman, and then use the first intermediate exchange with some lattice-based scheme, and then you have authentication, and then you have your McAleese key exchange, or you configure your combined mechanism in IKC init with ECDH and with some small lattice-based scheme, which at least prevents an attacker from breaking the code live in real time. Then you have authentication, and then you have your McAleese scheme. So in that situation, it could be like also come in handy, but it's definitely not a must. So it's just another thing to make it more easy and more the transition more smoothly.
You can also achieve this by doing classical key exchange like IKC init. Then I can intermediate with some small public key.
Yes.
Then authenticate, and then McAleese.
So it's, as I said, it's not a definite must, but I think it would make all of these transition periods more easy. And as we already agreed upon, it's a nice addition, and which should make transition periods smoother. And on the long term, the solution with more cryptographic agility, which allows more cryptographic agility, like the follow-up key exchange, the multiple key exchanges, should be preferred. So I think it's like two discussions. One, to introduce the small key exchanges, the classical together with one small PQC algorithm during IKC init, which would be like a separate track. And the other discussion is that we should it focuses on the beyond 64K draft. Sadly, we don't have measurements for mixed mode. What Valerie said, we expect them to be significantly better under unreliable network conditions. But already now for some network environments, it is a acceptable solution. But we think the McAleese key exchanges, or like all key exchanges that are that large that they require the beyond 64K draft, should at least be put after authentication to prevent this attack vector for DOS attacks, or especially memory exhaustion attacks. So
I think the next one is Scott, or there was somebody who just dropped out. But
I'm actually going to ask a question not about the protocol, but about your assertion that 20 seconds of delay is actually acceptable. I assume you are running this on a single connection between one gateway to another gateway, or one client to another client.
Yes.
Unfortunately, quite commonly we have a single gateway talking to dozens, hundreds, possibly even thousands of clients, and sometimes they all try to basically come in at about the same time. How would your protocol work in that scenario?
That is a good question, actually. So the test environment is just two gateways communicating over more or less, depending on configuration, reliable channel. Obviously, if you, but it's also confined to 100 megabits. So I guess if you have a central router or like central gateway, it will hopefully have more than 100 megabit of throughput, and just be more capable than that. Otherwise, I don't think it will be fit for such a scenario. And yeah, obviously also if you connect a lot of initiators at the same time, and all of them are send such large public keys, you will run into problems. And the 10 seconds we have here in our measurements for rather good network conditions will be surpassed. This is especially if you have a setup with thousands of peers who all try to connect at the same time.
I hope you can hear me as well.
Yeah, I'm sorry.
The thing is that we're not only talking about like really a lot of clients talking to a single gateway, because what we're talking about is like there's agencies, there's military stuff where you want to have this 3, 4, maybe 5 connections to other places. And those have to be really secure. And they expect us to use McAlee, something that they really can rely on. But on the other side, there might be hundreds of other clients. But I don't think that any mobile client will be able to use McAleese anyway. So we have to use something else there anyway. But when you only talk about those very specific lines, only thinking about like one location connected to the other location, it should still be okay with this delay.
Well, like even if you have like 10 or 20 gateways, and each of them has more than the 100 megabit of throughput, let's say that's 1 gigabit of throughput, it's roughly the same situation as the one we measured. Of course, real-time measurements with real-world conditions would be even more. It would give even more insight. But for these network confined variants of networking conditions, this might be a good solution. It's definitely not a one-size-fits-all draft, and it was never intended to be.
And we still don't have really like too many test setups. Like what we can do right now is like test within Germany. So over the internet is quite okay because we have some locations where we can test it. But so far we weren't really able to like test it worldwide. That would be something we want to do. So if anyone can help us out, that would be great anyway. So we might be able to get
I
some.
think we can go on to Valerie's
no.
question. He's also in the queue. Thank you.
I just want to add that I also performed some experiments with McAleese on UDP because it's not implemented. And with my result, well, I didn't have a network that emulates packet loss. It was just a 100 megabit test bed network and pretty dated stop, and it took about a few seconds to perform McAleese with this setup. Well, I don't have exact measure, but it's about 2-3 seconds for McAleese to complete. Just my experience with it.
Okay. So
yeah. Also, just one little note. The graphic you see there, which is rather high connection times or handshake completion times, is with a throughput of 1 megabit. So this is a really confined throughput, and so like not what we would expect a scenario to have, but it shows that it's really not the best scenario for this draft. Sorry.
all right, so I think we should be getting Can you hear me now? Actually, is my microphone okay? Okay, you can hear me, but I can't see my text there. But anyway, so we should be going forward to next presentation, which should be Valerie, which should try to speak up this time because there have been people complaining that you are too, you are not loud enough. All right, just say when you want to go to the next slide and so on.
So can you hear me? Am I loud enough? So it's group key management using IQ2. So next, please. The draft is about securing IP multicast, and this is a brief reminder of what multicast is, and I think you all this know about it. So it contains at least one sender and n receivers. And the packet, it takes advantage of multicast routing that delivers packet to all n receivers. And to secure this setup, this requires sender and receiver to share setup IPsec SA using the same keys. So there are two kinds of hosts in this setup. It's group controller key server, GCKS, and group members. So group controller key server is responsible for generating shared key and for delivering them to the group members at the time the group members join the group. So this involves a unicast registration protocol that is very similar to IQ2, and except that it is not created a child SA. Instead, it ends up with the shared keys that are delivered from controller to group members. So there is also a key protocol that can be done either via multicast or via unicast, depending on the controller choice. So the next, please. So, GIQ2 is intended to be used in IEEE 802.15.9 as a key management protocol for multicast. So I think Tero may correct me. This is data from the previous presentation. Probably something has been changed, but draft 05 version of STD 802.15.9 standard specifies that GIQ2 is used for group key distribution. So the next, please. So what is the current document status of the draft? It has been in development for many years, and a few implementation of early draft exists. And I'm not aware, I don't know if there is any implementation of the current version of the draft. It has been adopted by Psecme 2 years ago, and in 2020 it was a major rewrite. And since then, only minor updates were made, and the draft, well, I think it's mature enough, but I think it definitely badly needs a reviews. So by mature enough, I mean that authors don't see anything that should be added to this, and anything that should be removed from this. But definitely, it's only our opinion, and we badly need reviews. So next, please. So this is a quick outline of what major changes were made. And policy representation was changed. Before, it was IQ1 style, mostly using attributes, and now it's more like IQ2, using transforms and attributes. Attributes are used to represent variables. That's in comparison with enumeration. Things like transforms and so on. So that's why format of GSA and KDPLO is changed, and group key representation has been changed. Before, the group key were transferred in clear inside key distribution payload. So IKE implementation can look, can see them, and I think it's not good. And it was changed so the all key encrypted even inside KD payload, either using SKD derived key or using some keys, some other group keys. And this allows us to have logical key hierarchy as integrated part of GIQ2, because before it was some addition, some extension of GIQ2. The next, please. So we write it IANA consideration. So now it's more an extension to IQ2 and not a separate protocol. So we use IQ2 registries for new values. We extend them. And a lot of clarification has been added. I won't list all of them, but there are a lot of them. Next, please. So GSA payload. GSA payload contains policy necessary to participation in the group. So it contains a protocol, a traffic selector, transforms for algorithm method using the policy, and attributes for variables that change over time, so like initial message ID and so on. GSA payload format is now common for all situation of KEK, TEK, and GAP. And the gap, the difference of the gap is that it's distinguished by the value of protocol that is 0. Next, please. KD payload contains key material necessary for the policy in the GSA payload. So it contains one or more keys in encrypted form. There is a structure called the wrapped key, and it contains a group key that is encrypted with another key. And either it is SKD derived key or other group key. That's why we can get a logical key hierarchy capability by making a logical link of the keys inside KD payload that encrypts one with the other back to the root key. And well, next, please. And IDG payload contains identifying the group that GM want to join. There is no change. Next, please. So a few IQ2 payload are used. It's SAG that has the same format as SA payload, but slightly different semantics. And delete payload. Again, it has the same format and the same payload number, but the semantic is slightly different because it's allowed to delete all SAs, not only a particular SA. So next, please. There are new notifications compared to IQ2. It's some error notification like invalid GROM ID, authorization failed, registration failed, and a few status notification. The notifications that indicate that GM want to be a sender in the group, and newly added with the 0.1 version keys needed notification. That this notification is used with PPK when PPK is used. Because using PPK with GIQ2 brings a lot of problems because we need IKSA to be secure from the very beginning because we want to transfer sensitive information over it. So the approach that is RFC 8764 is taken when we create a childless IKSA and then immediately key is not going for GIQ2. That's why there is a very complex mechanism. And I also have a draft, an alternative weight for PQ, public for post-quantum key security, mixing shared key for post-quantum key security. And I think if we want to make this RFC work for GIQ2, we should consider adoption of this draft because it it uses IC intermediate significantly simplifies JIQ2 for use with PPK. So the next, please. And use transport mode is reused with slightly different semantics. Next, please. So thank you very much. And this presentation is a repeated presentation, and we badly need reviews. So I don't know, probably working group last call should be issued so that people start reviewing this draft. Because the draft is very complex and it should be reviewed. It should be reviewed very thoughtfully.
Okay, so I have one question. Does the system or the draft already support this IC intermediate, and or do you have a text for that?
I don't remember whether the text for that is in the draft, but I think that IC intermediate can be used with this draft with no change.
Yeah, my understanding is that it will be, and I think actually it would be a good idea to add that in there, so that we actually, have a clear text that you can actually use this with IC intermediate. But I think we can actually I think that's a very small change that we can actually, because I think it works without any changes. It just needs to be said that, oh yeah, you do the IC intermediate in the middle before the GSA out. And I think starting the working group last call is probably the best way to get the reviews, unless somebody has any other comments on this. I don't see any other comments, so I think we should be then starting with working group last call for that. Or does no? I guess nobody had any more comments. Okay, so I will probably start a working group last call for that document then quite soon. Okay, then we go to our next presentation, which is the announcing supported authentication methods for in IQ version 2.
Okay, this is also a repeated presentation. It's not new. So I just want to bring your attention to the draft because it is in the Psecme charter, and I think it is ready for adoption. So the next, please. So unlike IQ1, authentication method is IQ2 is not negotiated. So each peer is free to use whichever method it thinks is appropriate. And generally, it works very well. But in some situations, when peers can use several methods to authenticate each other, and these methods are not aligned at one peer, it is possible that initiator selects authentication method are supported by the responder. So it is also possible for responder, but less likely because once initiator indicates which authentication method it uses, responder has more information to choose the proper one. So the next, please. So the problem was first encountered when RSI PSS signature format appears in IQ2. So new initiator tried to use RSI PSS, while all the responder didn't support it, send it, authentication failed. And for initiators, there is no clue why authentication is failed. It's probably something wrong with credentials or something else. So if initiating new responders capability, they would have chosen PXS 1 and the SA succeeded. So the next, please. And so the problem is that peers have no explicit way to indicate a supported authentication method. There may be some indirect ways can be used, like set request payload, but in general, it is unreliable. And I think that with new signature formats and authentication method, especially if we think of post-quantum authentication method and hybrid ones, that only appear, the situation of misselecting may happen more often. So the next, please. And proposed solution. We can add a new optional status notification, supported auth method, to indicate so that each peer can indicate a supported authentication method. There is not a negotiation, unlike IQ1. It's only announcement. So each peer just announces which method are supported, so that the other peer can select one of supported authentication method. They can differ in different directions as it can be now. So in this case, it is not a negotiation. It's only announcement. And for certificate-based authentication, we can add an ability for peers to indicate which signing algorithm can be used, which each certificate authority certificate in the third track indicated in the third request payload. And we don't want to create a new IANA registries for this. So the next, please. So the format of this new notification is as follows. Notification data consists of list of supported methods, which has 3 possible formats. 2-octet format that only indicate for the methods that are not linked to third request payload at like pre-shared key or null authentication. 3-octet format that allows optional linking to third request payload, and multi-octet format that also indicates a particular algorithm by using ASN1 algorithm identifier. The linking to SA is done by specifying the ordinal number of the CA within third request payload for this particular method that is announced. Next, please. So it's an example. So how it can look like. So we have a third request payload with several CAs, each with different algorithm, and we have supported auth method notifications that link that indicates an algorithm identifier and link with algorithm identifier with a particular CA. So the next, please. So this notification can be used either in IKSA init and for responder and IKAuth for initiator, or next, please, or in IK intermediate exchange, just to avoid fragmentation. In this case, responder sends an empty supported auth method in IKSA init, just indicating that the real supported auth method notification containing a real information will be sent in IK intermediate. And this can avoid a potential fragmentation problem, because with this format, supported auth method can grow pretty well to tens or even 100 bytes in length. So the next, please. So this is all in the draft, and there are more details, and please read. And well, I think that the draft is ready for adoption. So that's all.
Paul,
Yes.
go ahead.
Hello, people can hear me?
Yes, now.
I think so. Okay. So my question is that there's a bit of confusion, I think, between what is a configured authentication method and what is a supported authentication method. Because if a responder supports RSA PSS, but it only has a connection configured for pre-shared key, then that information is kind of useless to the initiator, right? And so I'm really confused so I can understand that the initiator can send what it's expecting to do, because it knows the authentication it is going to do, because it knows which connection it's trying to reach. But the responder might have multiple connections configured with different authentication mechanisms. And so I'm just trying to clarify, like, are you only looking to announce the supported authentication methods as in the implemented ones and not like the allowed ones? Because there's some confusion for me there.
I think it is allowed once, but if you can, of course, if you can tell what is allowed for this particular connection, of course it is allowed once, not implemented. So,
okay, but so then the problem becomes on the allowed side, the responder has no way to answer anything until it has received the auth payload from the initiator. Because only then does it have the ID payload, and only then does it know what's configured for that specific peer.
yes, that's the problem. But still, it allows initiator to properly decide, to properly select authentication method.
But now you talk about supported, not configured.
Yes, it is allowed for initiator and supported for responder. It's a little mix of this. Because, well, actually, if responder can guess, for example, from IP address, then it is allowed. But if it cannot guess, then it is supported.
So yeah, I don't know. It's a little confusing to me if we can do this or how much it actually helps us. But I'll reread the draft and think some more.
Is there any other comments on this draft? Any comments about not whether this document is ready for working group adoption? If I think it should be, because I mean it's a starting point for this draft document, and I think it's in the charter, so we should be making it as a working group document and then start processing it forward. It seems to be annoying that my Meet Echo is always complaining that it doesn't hear me at all, and I don't see any of my indication that I'm speaking, but everybody is acting like I'm speaking, so I assume they hear me.
I can hear you.
Yeah.
All right, so if there's no other comments on this topic, I think we will then, start a working group adoption call for that. Or Christian, do you have some comments on this or something else? No? Okay. So I think that's for it. Then we have any other topics, or Valerie, do you have other topics?
Well, I want to bring attention to a few drafts that are also waiting for adoption. First is revised cookie processing. Well, we discussed it a few IETFs ago. I want to know whether there is any interest in adopting this draft. Then another draft that is waiting for adoption call is alternative mechanism for mixing per shared key that I mentioned when I talked about GIQ2. So if we want use PPK in GIQ2, I think that we should seriously consider adopting the draft, because it solves a lot of problems well, doing PPK in GIQ2 is very difficult. It requires a lot of additional round trips and unnecessary delay of SA setup, because you need IKSA to be secured from the very beginning. So if you want PPK to be coupled with GIQ2, then we should consider this alternative way. It is very simple. It's only 7 pages long. And I also think that draft beyond 64 kilobytes is also is worth to adopted by this group. Well, we've talked a lot about using macOS and all these mechanisms with long public keys, and not only for key exchange method, but for signature method too. And so I think that, well, probably not immediately, but I think that we should consider adopting the draft. So that's were my points. Thank you.
Yeah, I would propose you send an email to the list on each of these specific draft and ask for there. Also get people, if there people are interested, to comment on that and so forward. Or people can actually, we have still 5 minutes actually. Probably better do that in email. All right, so the next one is Paul. I guess, in the queue.
Okay, I'm not sure how I raised Christian, but there's another draft, the multiple essay ones, where we clarified some things. We asked some input from the working group on a mailing list, and we did not hear any objections to our proposal. So we went ahead and published a new version of the draft that did not have QoS in it. That really simplifies the draft, and so I'm hoping that people can read it and give comments on it, because we have implemented it, and we really are looking for getting our more than the 3 gigs per CPU implementations out there. So we have implementations, but we really want this document to move forward. So
wasn't there just before this IETF some comments about somebody saying that they should be combined with other draft or something like, or have this, I think there was some discussion in the list before the IETF, or I don't know, I might misremember. Okay, but anyway, so let's bring that, let's keep that on the list and continue there and see if people are interested. Okay, Christian.
I will say, Paul, we are interested in looking at TFS stuff on in Linux. I don't know if we're going to get to it, but if we do, I suspect we're going to be looking at your stuff as well to get the higher rates. In any case, I was just going to say the new IPTFS draft is published and posted. We only have 4 minutes. If we had like 20 minutes, I was going to say I'll share my screen. We can go over the diff, but I think we're out of time for that. I think I got all the points in there, though. So if people could take a quick look, that would be great.
All right, good. That's perfect. All right. Any other topics on this? Okay, my list of things that we should be doing is to have an working group last call for GI version 2 to get more reviews on. Start the publication of the IPTFS drafts when we get this, when we have, time to read the draft and verify that it's all there. And then probably start the working group adoption calls for draft BTV add IPsec IK for the additional, this DNS stuff. And then we have the IK version 2 out announced. Anything else that I'm missing on my to-do list? I guess not. So I think, and I don't expect anybody to have any, or does anybody have still any other business? If not, I think we are then done. 3 minutes before time.
Excellent time management.
Yeah, I was looking at like somebody, we might run out of time, but we did it. All right. Okay. Thank you for everybody. See you in the mailing list.
Well. Bye.
Thanks, everybody. Bye-bye.